Good morning, everyone. Thank you for joining us today. We hope that you enjoy the afternoon yesterday and all the days spent here with us. I would like to introduce you our Vice Rector to International Affairs, Professor Bruno Rubino. I leave you the floor. Thank you.
So, morning and welcome from my side. Sorry that I was not here yesterday, but I hope that you enjoyed the first day of staying with us here in the university. I hope that you start enjoying the city, even if during the autumn could be less interesting than if you come during the spring or May, June. That's maybe a better period to visit this area. Tomorrow morning I will come back again to give you a short presentation of the university with the idea that to increase or to create some links with your university in the field that you assume that could be possible to do that. So please, if you have some ideas on something that we can develop together, tomorrow morning we can discuss and tell me and the colleagues here, Professor Tozzi or Alessandra and Fausta, if you have some specific idea of cooperation that we can have in between L'Aquila and your institution. We are open for this. The Staff Week is an occasion to start cooperations. So thank you for being with us during this week, and again, hope that you will enjoy today as well. I know that you have a quite long day with presentations and so on, so I will not take more time for today, so let's see tomorrow then together. Thank you.
Okay, good morning, everybody. I'm glad to present you the first speaker for today, Professor Donatella Donati. Donatella Donati is an assistant professor in logic and philosophy at the Department of Human Studies here, and she holds a PhD in philosophy from the University of Nottingham. Her main research areas cover fields such as metaphysics, time philosophy, and of course, artificial intelligence. And today she will deliver us her presentation titled AI Ethics in Action, and she will give us a quite interesting view on the role and challenges of ethics in the increased and accelerated use of artificial intelligence in our lives. And I leave the floor to you.
Thank you very much. Thank you. Good morning, everyone, and thank you so much for having me here today. I'm happy to be here, and I'm so sorry I couldn't participate to yesterday events. So yes, today I'm going to talk about AI ethics in action. I'm a philosopher, so of course I will give you a theoretical perspective on AI ethics. I won't tell you how to use it. I'm going to tell you what it is and what is the role of an AI ethicist. So of course, as you know, philosophers do a lot of critical thinking, conceptual work. So what I'm going to do today is to give you an idea about where to locate ethics and AI ethics within the domain of philosophy. And then I will tell you something about the studies that philosophers and jurists as well are developing in another area. So they are trying to understand which are the skills and the tasks of AI ethicists when it comes to their role in a company or in the society in general. And I will briefly tell you something about a competency framework that a group of scholars in AI ethics have developed. So, but first of all, I'd like to start about the main question: what is ethics? What is applied ethics, and what is AI ethics? Actually, AI ethics is a very narrow, let's say, discipline that it's in a domain of ethics. So first of all, what is ethics? We are in the domain of philosophy. And we can say that there are, as you know, several areas of research within philosophy. There is metaphysics, there is philosophy of language, logic, philosophy of science, epistemology. And of course, this list doesn't mean to be exhaustive at all. But all of these areas ask different questions about reality, about language, about the mind, about free will, for example, about knowledge. And you can locate all these questions within these sub-areas of philosophy. When we talk about ethics, we are in the domain of moral philosophy. So we are in the domain of philosophy that asks specific questions about human beings and about their behavior. So ethics can be found in this sub-area of philosophy. And what is ethics? Of course, this is a definition of normative ethics that is, again, a specific type of ethics. There is another kind of ethics that is descriptive ethics, but we are not going to talk about it today. We are going to talk about normative ethics, that is the ethic that is more related with the AI. And ethics, in this sense, is the area of philosophy that, broadly speaking, is concerned with standards for right conduct and moral evaluation. Generally, such a theory will give an account of right action and try to give some idea of what makes it right. Whatever the focus, moral theories are primarily concerned with two things: providing moral guidance, and the second thing is the moral evaluation of human conduct. Central concepts such as right, wrong, good, bad, permissible, and impermissible need to be articulated to accomplish this task. And I would like to bring your attention on this last sentence. Different moral theories spell out application of this concept differently. So ethics is concerned with telling us what is good, what is bad, what is right, what is wrong, what is the right conduct, and what is the wrong one, what is a permissible action and an impermissible action. But this last sentence says us something very important. Within the domain of moral philosophy, different theories spell out this concept differently. So according to a theory, something is good and something is bad. But according to another theory, the very same action can be seen not as good or not as bad as for the other theory. So within moral philosophy, there are different theories that define this concept that are listed here differently. So there is no universal moral principle that says us what is good, point, okay? So this is something very important, and this is something that makes things, when it comes to AI, quite tough to understand and to solve. So we started from philosophy, we went in the domain of moral philosophy, then we are in another sub-area of ethics, that is applied ethics. Also, ethics comes in different kinds. So there is ethics, meta-ethics, and then there is applied ethics. Applied ethics is marked out from ethics in general, but its special focus on issues of practical concern. It is concerned with ethical issues in various fields of human life, including medical ethics, business ethics, environmental ethics. Also here, the list is not exhaustive at all. Within these broad areas, it engages with policy issues resulting from scientific and technological change, and with the evaluation of social and legal decision-making in public areas, such as healthcare, policing, media and information, and the world of business and finance. It is also concerned with professional codes and responsibility in such areas. So applied ethics is the practical ethics. It tells us when we are in this domain, we use the ethical principles that are developed in the more general area of ethics to a specific domain. So here we have the example of healthcare, policing, information, media. So we are applying the moral principles that we had a look at in the previous slide to a specific area. And AI ethics is just applied ethics in the domain of AI. So we are in a very narrow space within the field of ethics. And as you know, AI ethics is a notion that is not used just within the domain of philosophy, but nowadays we can find this notion basically everywhere. If you go on a website of a company that has to do something with information, with technology, you will definitely find a page dedicated to AI ethics. Here, of course, I took an example, and I took the example from the IBM website. And also in this case, they give a definition of AI ethics. So they say that ethics is a set of moral principles which help us discern between right and wrong. AI ethics is a multidisciplinary field that studies how to optimize the beneficial impact of artificial intelligence while reducing risks and adverse outcomes. Good. This is a nice definition, and it's not even wrong. But the main problem here, and we will talk about this in a bit, it's this. Ethics is a set of moral principles which help us discern between right and wrong. But we saw that actually within ethics, there are different theories that tell us that what is different wrong actually is not fixed. It can change, it can vary. So saying something like that is not, let's say it's not wrong, but it's not even accurate. And things actually are not so easy. AI ethics is a lot of different things. And AI ethics research can have different focuses. So as we said, AI ethics is a growing field. And actually, nowadays, you can find within the academic research plenty of scientific papers that deal with some of other aspects of AI ethics. And there is a growing interest from, of course, again, just to relocate myself, I'm a philosopher, I know quite well that literature, a lot of philosophers are getting interested in different aspects of AI and AI ethics. And also within AI ethics, you can find two different perspectives with which you can see AI entities, or AI systems. And you can see AI as an object, for example, or as a subject. And seeing an AI system as an object or as a subject makes you ask very different questions. So there are different kinds of, there are different approaches to the research when it comes to AI within the field of applied ethics. And here it's just, of course, I will roughly tell you something about these two different approaches to the research. But when it comes to seeing an AI as an object, you are wondering which are, you're trying to understand which are the ethical principles that this system should respect. So you will have, I'm sure that you heard a lot talking about principles such as transparency, fairness, non-maleficence, responsibility, privacy. So these are the guiding principles that should, again, guide the behavior of AI seen as an object and our interactions the human interaction with these systems. And seeing these AI systems as objects goes beyond legal compliance. So makes us ask questions, new questions about the moral behavior of these objects. Because of course, AI systems are, let's say, new entities, new kind of agents within our society. And of course, they allow us to ask new questions because their behavior is not is not perfectly aligned with the behavior of human beings. So the question that we ask about the way they act are quite different from the ones that we ask when it comes to human beings. And then we can see AI as subjects. And also in this area, there are key moral questions. So for example, how should AI be programmed to act? Do AI systems have a moral status? So I've just used the word in a very uncontroversial way, but I say that the AI systems sometimes are seen as agents. But what does it mean to be an agent? Usually within moral philosophy, being an agent means to have a moral status. So since these AI systems are starting to act autonomously, they have a role in decision-making processes, we are starting wondering what kind of agent those systems are. And also, can AI be held accountable for decisions? Of course, this last question has a lot to do with legal theory. But of course, when it comes to moral accountability, moral responsibility, also philosophers have something to say about this. So you can approach AI ethics from different perspectives. And sometimes when I work with computer scientists a lot, I'm in a multidisciplinary group, and I work with jurists, with computer scientists that are very keen in understanding which are the development when it comes to the ethics of AI, and so we collaborate a lot. But I also teach at the Department of Information Engineering, and there are a lot of colleagues that are quite skeptic when I talk about AI ethics. And so I just summarize this skepticism with this question: do we really need AI ethics? A lot of people say, no, we don't really need AI ethics. And this is let's say, a lot of computer scientists think that AI ethics is useless, and sometimes it's a way to slow down the process of the progress of the development of technologies. A lot of people think that it's just sci-fi, and it's not a real threat. So when we think about AI ethics and all the problems that AI ethics try to tackle, they just say, no, you are wrong. These are not real problems. You are just thinking about a dystopian future. Something like this will never happen. But are you sure? Are you sure? Do you think that the problems that AI ethicists deal with are just future problems that unlikely will occur? Well, no. AI ethics is something that is urgently needed today, because there are several ethical issues that must be solved. So here I just brought you some examples about the ethical impact that technologies can have on our life. And you must know, I don't have time today to talk a lot about what ethics really is. But ethics has to do, of course, I just told you that it has to do with good action, wrong action, good actions, bad actions, permissible actions, impermissible actions. But all of this has to do with our well-being. So the moral principles should guide our behavior when it comes to our interaction with other human beings. And so, of course, this is because we must somehow protect our well-being. And when I say that all of these examples that I brought here have an ethical impact on our life, I'm saying that have a huge impact, actually, on our well-being. When I say our well-being, I mean our as human beings. So, again, just a few examples to convince you that AI ethics is something necessary. The first is a paper that came out in the MIT journal, and this one has been published in 2023, so we are talking about recent cases. And it's called Unmasking the Bias in Facial Recognition Algorithms. Have you ever heard about the discrimination against some minorities that facial recognition system may perform? Have you ever heard about, for example, Joy Bulamini and Timnit Gibru? They are quite famous software engineers. Not sure. I will tell you something about it. So basically, Joy Bulamini was because now she quit her job. She was working at the Media Lab at MIT, and she was playing, let's say, with a facial recognition system. She's a black woman, and she realized that this system was not recognizing her as a human being. So she tried again and again, and one morning, she was using this system to play a creative game, let's say a creative game, and she was using it as a mirror, but it was not recognizing her. So one morning, she put on a white mask on her face, and the system recognized her as a human being. So she understood that the system was biased against her skin color, and maybe gender as well. So the problem was that she was a woman and she was black. She started working on this algorithmic bias, let's call it with its name, and she started working with it with another software engineering, that it's Timnit Gibru, that used to work for Google. Now she's not working for Google anymore as well. And they realized that most of the facial recognition system in the market were biased against black women. And this was because they were trained on data sets that were not representative of women and black people. So they worked on it and they tried to solve this problem, and they created a new data set that was more gender and gender balance, and they also used a lot of images to represent both people of different skin shades. So this was a first problem, but it's not completely solved. We still have a lot of systems, not only facial recognition system, but different systems that are biased against some minorities. And I have students who are working on specific algorithms and systems to detect the biases that they have. So this is the first problem, discrimination against women and against black people. Another example, the one on the bottom right for you. Facebook translates good morning into attack them, leading to arrest. So this is another AI system. It was an automatic translation system that was used by Facebook. And basically what happened, this happened 4 or 5 years ago, 7 years ago. A Palestinian man wrote good morning in Arabic on Facebook. And the translation tool that was, again, that it's still automatic on Facebook, translated that word with we'd attack them in Hebrew, if I'm not wrong, and fight them in English. So clearly it was a wrong translation. The Israeli police, as you can guess, arrested the man. Then they checked this and released the man after a few hours. So, as you can see, here there is another huge social and ethical problems. Also, translation tools are not representative of some languages. So they perform worse than in some languages than in another set of languages. Do not need to say which are the languages they perform better with. So this is to say that again, this is another problem of discrimination. Here, actually, there are two main problems that are ethical. The first one is about discrimination against, again, group of people. The second one has to do with the fact that usually human beings rely a lot, trust a lot these systems without asking whether they are performing good. And this second problem is called the automation bias. It's a bias that we have towards technology. Just 3 other examples, again, if you need them, to convince yourself that AI ethics is something that we should use when it comes to the development of technology. You know that a lot of companies are working on the development of autonomous cars, so driverless cars, but these cars are not performing that well. So there have been cases where self-driving cars kill pedestrians, and this is a case something that happened in Arizona a few years ago, and there was a huge problem about accountability. So it took quite a long time, actually a few months, to understand where to locate the accountability, the responsibility for this failure of the system. And it's not easy to distribute responsibility when there are a lot of people in play. So here, in the case of the Uber car, there are engineers that work on the programming of the car, there are the developers, there is the legal part that guides let's say, the behavior of the machines when these machines go on the street, and there is the owner of the machine. I mean, it's let's say it with the right word, it's a complex socio-technical system. There are a lot of people that play in the development of this technology, and when the technology fails, it's not easy to understand who should be held accountable for the failure. Other 2 cases, the New York lawyer sanctioned for using fake ChatGPT cases in legal brief. I laugh a lot when I think about this. So basically, this is a lawyer that used ChatGPT to write his legal brief, and ChatGPT hallucinated and gave him cases that were not existent. So he went in the trial and he talked about, he made the brief, and later on they found out that the cases that he was reporting during the trial were fake cases. So the LLM hallucinated, but the lawyer didn't check whether those cases were real. So he just used the LLM to write his to write his brief, and went to the trial just without checking. Again, we have two problems here. Again, one is the same that we talked about earlier on. So it's the automation bias. That is the lawyer that trusted blindly the LLM. And the second one is the hallucination that LLM perform. So a lot of times LLMs tell us something that is false, give us fake information, let's say so. Last example, but I could talk about this for 12 hours, actually. There are plenty of examples, unfortunately. Google apologizes for Photoshop's racist blunder. So basically, here it's a tool that recognizes the objects in the pictures, and this photo apps was given a picture of 2 African people, and the app told the user that they were gorillas. There was an official apology, but you can see that, again, there is a discrimination against people. And this affects, again, a lot our well-being. And it's, of course, we could easily say that the ones that I talked about, the behavior of this technology was not fair for some reason or another. And all of these cases have to do, of course, with law, with AI engineering, have to do with sociology as well, but have to do with philosophy too. And so the ethicists that come from philosophy are deeply needed to understand at least which are the moral principles that should guide the development, deployment, and use of these technologies. And a lot of people are working on this. And I'm proud to say that, as I said earlier on, I'm working in a multidisciplinary group where we try to understand how to implement somehow morality within technology. And there are various approaches to this, to understand how to do this too. This is a very famous example. I don't know if you know it. It's called the moral machine experiment. And it's an experiment that has been thought about by a group of engineers, jurists, sociologists, philosophers that are mainly based at MIT. And at first they thought, okay, let's try to ask people which are the moral principles that they prefer to implement the technology with. So they developed this experiment, and it's mainly focused on driverless cars. And they ask people worldwide, how should these cars behave when they are on the street? So it's clearly, this is an experiment that is based on experiment well known to philosophers, that is the trolley problem. So basically what they do is this. They give, you can do this, if you can go on this platform and play with it. You can start judging. So usually you have a couple of scenarios where an accident is unavoidable. So there is the car that has some passengers on it, and usually there are pedestrians. And again, there are conditions for which an accident is unavoidable and someone has to die, either the passengers or the pedestrian. And there are several different kinds of scenarios, and the user is asked to say which is the preferred one. So, example, there is the red light on, pedestrians are crossing the street, for them the light is green, and there is a driverless car that has 5 passengers on it. Unavoidable accident, who should die? The people who are crossing the street or the passengers on the car? And you go on for 13 times like this. And by doing this, these scholars say, okay, let's see which are the preferred action for people worldwide, and let's try to deduce from this the moral principles that usually people follow when it comes to decision-making of autonomous technologies. But unfortunately, it was, let me say, it was a mess, because they couldn't get universal moral principles. Because someone this morning, Professor Tozzi, will talk about this, I think, because I read the title of the talk. Actually, morality is relative. So depending on your culture, on your background, on your experiences, depending on, there are several factors that affect the way you reason from a moral point of view. So it was impossible to get from these moral decisions universal moral principles. And indeed, then they made an analysis about how the moral decisions made on this platform were distributed worldwide. If you are interested in this, you can go on this platform, and there are all the publications. You can play with the experiment, you can see what they found out. But unluckily, I mean, they couldn't understand which are the principles that should guide technologies worldwide. So it's tough to understand not only how to implement moral principles within the technology, that is a huge problem, but it's also very tough to understand which are the moral principles that you can implement the technology with. And this is a huge problem. And of course, the problem is twofold, we can say, because I told you at the beginning of the talk that different moral theories, so if you work bottom up, if you work top down, so if you start from the principles, it's tough to implement the technology with the right principles because there are several principles that tells you what is right and what is wrong. And then it's also tough to work bottom up. It's also tough to gather data and deduce which are the principles because the data are too diverse. And so it's very tough to deal with the problems that AI ethicists work with. And the fact is that, I mean, within AI ethics, there are a lot of issues that are hard to be solved. But in the last few years, the role of AI ethicists is needed. And there is no much work on the figure of AI ethicists. So it's not clear what it is, an AI ethicist. And this is the first study that was performed by Cucchiaro, Morley, Novelli, Panay, Tartaro, and Floridi. I don't know if you have ever heard about Luciano Floridi. He's the pioneer, let's say, of AI ethics. He's the director of the Yale Digital Ethics Center. And last year, I mean, it's very recent, this paper, came out with this paper that is, who is an AI ethicist? An empirical study of expertise, skills, and profiles to build a competency framework. We don't know what an AI ethicist should do within a company, for example. And so they started thinking about this. I will try to be quick on these points, but of course, the fact that we don't know which are the skills and which is the role of an AI ethicist within a company, for example, is a risk factor. Because we may have people that lack of expertise within that domain. And of course, insufficient domain expertise for a company and for society as well is a significant risk. We all know that it's very important to have domain expert within different domain. Indeed, risk management frameworks emphasize the role of experts in providing crucial guidance. And of course, this is true also for AI. And managing AI risk requires diverse viewpoints to address potential impacts. How much time do I still have? 10 minutes? Okay, I'll try to speed up. So it's quite important to understand which are the skills and the tasks of the AI ethicists within our society. And of course, this role has been underexplored, as I said. Let me go quickly, since I have just a few minutes left. The main problem, and this is something that I'm really keen to say, is that companies use these AI ethicists just to do what is called ethical blue washing. So companies say, the one that I showed before, the page on AI ethics, but I can show you another one here. Don't worry, we care about AI ethics. We have people that are expert on this, and we do the right thing even if it's not easy. The problem is that AI ethics is used as a slogan that is most of the time empty. And this, of course, is a problem that is called ethics blue washing. So they have the label, but actually they don't know what they're doing with that. And so far, the AI ethicists have been technical researchers, data scientists, engineers, non-technical researchers, policy analysts, managers, directors, and so on and so forth. So there is no precise background for someone to be an AI ethicist. This, of course, creates a lot of problem because it creates the problem of the lack of expertise that I mentioned 2 minutes ago. So let me go quickly. I'm sorry about this. This group performed a study that has 2 dimensions. One is empirical, that shows that within Europe, this is, of course, it's focused on Europe, there is a growing need of AI ethicists, and they performed this study in 2023, and then they compared with another search that they performed in 2024, and they saw that the need is growing. If you are interested in this, drop me an email, I will send you the data. And so the job market is asking for AI ethicists. But they also worked on the normative dimension, and this is the most important part. So basically, they tried relying on competency framework of other figures that have to do with ethics. And I'm thinking about the American Society for Bioethics and Health, that it's a society that it's used a lot in the US health environments. So there is this figure of the AI ethicists that help in decision-making processes within health environment. So they relied a lot on this competence framework that was developed by this society, and they tried to build a competency framework for AI ethicists. And just to show you how tough it is to be an AI ethicist, you should have skills that are academic, performative, and practical. I'll go straight here. These are the tasks that are required for an AI ethicist, and they are a lot, and they vary across contexts. And these are the skills required for AI ethicists. And these are the results that they gathered after a long research also within the job market. So people ask for these skills when they want AI ethicists. So it's a figure that needs to be thought about more. I mean, let's say it's quite important to regulate, let's say so, and to narrow down the skills and tasks that an AI ethicist should have within society and within companies. And it should be a figure that doesn't need to do ethics blue washing, but should really do some important work within a company. And I mean, I think that I can stop here. Here it's all the work that we should think about and we should do when it comes to AI ethics and to the figure, the professional figure of the AI ethicist. And I think that I don't have time anymore, so I will stop here. Thank you.
Thank you, Professor.
Now, this part was quite quick. I understood that I was running out of time, so yeah.
Okay, so we have a little space for Q&A if you have questions for Professor Donati. Okay.
Hi, good morning, everyone. In a hypothetical scenario, if AI becomes conscious, should it have rights or no?
Sorry, can you say it again?
In a hypothetical scenario, imagine if AI becomes conscious, should it have rights or no?
So this is a very tough question. And it has a lot of answers. I tell you what I believe it's to be the most interesting answer. So there are people who are working on this. Again, consciousness seems to be something quite far in the future for what concern AI systems. But there are people who are trying to develop this prudential approach. So they say, these are different kind of agents. They reason in a way that it's quite different from ours. We won't have probably consciousness similar to our own. But if they develop something that is similar to our own consciousness, maybe we won't understand that. So we should be quite prudential when it comes to these AI systems that are very sophisticated, and we should start thinking about rights that should protect them. I find that research is quite interesting. I'm quite skeptical about it, but yeah, that's what I have to say. But we can discuss about this, for hours. Thank you.
Good morning. I have so many questions, but I'm from the field of literature, and I'm a big fan of an author, American author, called Isaac Asimov. Mm-hmm. Isaac Asimov was, I think, the first AI ethicist because of the three laws of the robotics. Yeah. And I want your opinion. And also Philip K. Dick with electric ships. I think it's not so. It was a slide. It's science fiction. It's all science fiction. I think it's not. No. It's kind of real problems that we face in the future. Yeah. I think the field of literature can help the hypothetical problems of AI. It's my comment, and I want to know your opinion, Professor.
No, I completely agree. And you reminded me of a slide that I use. It's just science fiction, and you talked about the three laws, right? Yeah. So it's not just science fiction, and I didn't want to talk about this today actually, because again, this opened up a huge discussion about it. But I'm sure that you are aware that a lot of autonomous weapons are used today. And those weapons are used to somehow affect, again, the safety and the well-being of people. So of course, it's not sci-fi at all. There are a lot of drones that target people according to a set of principles that are given by other human beings. So I completely agree with you. It's not sci-fi, and it's something that we should think about when it comes to regulate such system. I'm sure that you are not satisfied with this answer. Sorry. You want to know more about the Asimov law? If I think that they can guide the... Yeah. Yes, of course, it can be a guide, but it's not. It cannot be the only one. He can be considered as the AI ethicist, but of course, those laws can be declined into various different principles, moral principles, let's say so. So it's again, there is a problem of moral relativism and so on and so forth. So yes, but it's an interesting question. Yeah. Thank you.
Thank you very much for your very interesting talk. As there was not much time at the end for you to describe these necessary skills for AI ethicists, for me it seems that we are in need and finally for a return of centrality of philosophers and people who work, psychologists, social workers in the center of this. Do you actually see that as you had a look at these job applications, whether these are the skills that are required?
Yes.
Practically.
Yes. Thank you for this question. It's very interesting and on point. So yes, the skills that are required are a lot, and they are about different domains. So you see that there are skills that have to do with psychology, skills that have to do with philosophy, skills that have to do with engineering, skills that have to do with law. So there are a lot of skills that come from different domains. And this is the reason why the AI ethicist within, as a professional figure, has to have a lot of, a tough education, let's say so, because it comes from different domains, and this is not the only problem. So the study that I showed you, where there they say that it's not just a matter of skills, of knowledge, it's also a matter of interaction. So the AI ethicist should be an educator, a researcher, a scholar, and should guide the interaction within the companies she works within. So it's very tough. And I'm not sure that there are already people so well-formed. It's more about, I think that it's more about creating teams that work jointly on those tasks. And it's more reasonable as well. Thank you.
Okay, thank you,
Thank you.
Professor,
Thank
for your
you.
rich presentation.
So now we have a remote connection with Professor Giovanni Stilo. So I kindly ask my colleagues to start the connection. Here we are. Hello, Professor Stilo. This is Doriana.
Good morning.
Good to see you.
Good to see you. Hi, everybody.
So-
Sorry, I wasn't possible to be there on site at the end, but I hope the presentation and the talk would be interesting in any case.
Okay, I'm sorry,
And,
Professor Stilo, let me briefly introduce you.
Yeah.
Okay, so with
you.
great pleasure to introduce Professor Stilo, who is currently core faculty member at Lewis Business School and associate professor of artificial intelligence, data mining, and machine learning at Lewis Guido Carli University. He's been director of the master's degree in applied data science and associate professor of computer science at the University of L'Aquila. And his research focuses on reliable and applied artificial intelligence with particular attention to explainability, bias, and fairness. And he was included among the 500 Italians who matter in artificial intelligence in 2024. The title of his speech today is Artificial Intelligence and the Right to be Forgotten, How Machines Learn to Unlearn. The floor is yours, Professor.
Thank you very much for the warm welcome. So I will try to share my screen, so I hope it works properly. Okay. Are you able to see the slide? Can you confirm that you can see the slide?
Yes.
Okay. Okay. Good morning, everybody. So, one clarification. So, first of all, I'm a computer scientist. So, and honestly, I don't know exactly which will be the technical level of the audience. So, to understand the problem of learning, basically, I will go through also some technical stuff that are for, let's say, the non-expert, or maybe for the less expert. So, what it is the aim and the core of the today talk. So, on one side, we talk with the colleagues about artificial intelligence in general, with ethics and other interesting stuff. And as was mentioned in my previous career, I was interested in explainability and bias and fairness problem related to artificial intelligence. In the last year, basically, I've shifted to this new problem that it is called machine unlearning. Machine unlearning is specifically focused on how it is possible to forget something that was previously learned by a machine. This is more a general picture. And so that was the idea of the talk today is let's understand on one side what means from my technical perspective learning, and learning from several, let's say, point of view, which are the possible learning that it is today in place and that is behind all the systems that are widely adopted by a large audience. And then let's understand what means unlearning and which are the critical aspects of this new emerging field. Okay, so I don't know how it works, if you are feel free to interrupt or what, let's try. I don't know if I can have the camera on the audience, so I can maybe, while I'm talking, I can see how the audience react. Is that possible, or is not possible? Because otherwise I don't have any feedback in any case from the audience. Okay. But I don't have any feedback neither at the moment. So I will go forward. So we said that we are in the field of artificial intelligence, but the field of artificial intelligence is a very wide one. So from the theoretical point of view, artificial intelligence is any kind of system or program that it is able to learn and reason like humans, or if you like, mimic the humans' behavior from many points of view. The most simplest one is looks like to be human in the answer that he proposes. It's not so simple, but is what we are facing today mainly. This is not the only possibility, but anything that it is somehow looks like to be human, it is somehow something that it is artificial intelligence. Inside the artificial intelligence, there are the machine learning approaches where they have the ability to learn something without being explicitly programmed. What it is the paradigm here of the machine learning? That they basically learn from the experience. What experience it is? Experience is the data that they receive. And we will go through more specific examples of that, because they receive it, basically the input data and potentially the output data. We will discuss later. In the subset of the machine learning, there is the deep learning, that it is a very sophisticated model, but conceptually they are not so different from the machine learning one. So it's basically something more complex, but the behind approach is remain the same. Well, just to have a better overview on the kind of learning that can be made, here we have the artificial intelligence, the machine learning, which comprise the supervised learning, the unsupervised learning, and the reinforcement learning. What we are talking about likely today is about supervised and unsupervised learning, because those two are somehow the two main approaches needed as well for generative AI. And as you can see here, deep learning is just a technique that it is transversal to all those kind of learning activities. Well, but let's start with the simple case. No? The simplest case is the supervised learning. No? Here, what it is the task. So we know that the machine learning and the supervised learning is basically learn from experience, so learning from the data. And here, what we want to learn is a mapping function that connects the input to the output. So suppose you have a set of examples that are part of our real life, encoded in a certain way, and we have a set of outcome. A set of outcome, from our perspective, might be a prediction. I will go to concrete example later. But we have this kind of tuple, so we have already that. But what we would like to conceptually learn is, in practice, those arrows. So the mapping function is exactly this part of the system. Because if we learn, if we know which is this mapping function, then we can apply later two different input to receive an output that is coherent to what we saw in the past, the so-called training data. And here are some concrete examples, no? And also some naming. No? The first example, very simple, is the regression. Now, what it is the regression problem? The regression problem is, okay, I have a set of information in input. For example, I would like to predict the price of a certain house. Okay, so what I have in input is how many is the size of the house, how many bedrooms, the previous price, and how many parking slots. Those are information that characterize, no, the house, and those are encoded numerically. And what we would like to have in output is the predicted price. Fine. This is the most simple case. And what we are going to learn, as in the previous example here, is the function that maps those input, those kind of houses, to a certain price. The price is a scalar, it's just a number, okay? And this is a very simple case, but just to understand that we can learn this function of mapping from the input to the output, from the past experience that it is this kind of examples is the data that we collected. Fine, more sophisticated example, but that doesn't change in their essence, no? Is the multivariate regression. Here, what it is the point? The point is that instead of having something that are conceptually fixed, because we can describe any house by their size, their color, their characteristics, on the opposite, we might have, for example, different sides of molecules, and as output, we want to have not just one number, but a tuple of numbers, the freezing point and the boiling point, for example. It's still a machine learning task where we still want to learn the mapping function that goes from the input to the output. Fine. Nothing new from our perspective. It's just more complex. More complex because we have a more complex input and a more complex output. And this is anything that we are moving forward. It is, in this first part, are examples that are increasing in complexity. No? Because here we don't want to, let's say, have as an input something that have more or less a fixed or a fixed structure, but we would want to have, for example, natural language that change in its content and also change in its length. And the output here, it is a binary classification that might be, for example, if a review of a restaurant or of a service in general, it is a positive or negative review. And so, again, here, what we would like to learn is a mapping function between the input text and the positive or negative class. And that's why it is called binary classification. But again, from our perspective, we are still in supervised learning. More complex scenario, we have a piece of audio that it is our input data, and we would like to classify the output, that input, as one of the possible class of music, like classical, electronic, hip-hop, jazz, pop, metal, and so on. So here, the problem is called multi-class classification, because we can decide which is the class to have among a set of known class, and we still want to learn the mapping function between the real-world input and the real-world output. And all of that is done by having examples. Example is that we have a collection of audio files, and for each file we already know which is the class they belong to. More sophisticated one, similar to the previous, but here instead of the audio that have a certain data complexity, we have some images. Here we have an image of a bike, a bicycle, that it is encoded, and what we would like to have, similarly to before, is still having a multi-class task where we decide that this is effectively an image of a bicycle. And from our perspective, the setting is still the same. We are still working in a supervised setting where we have this tuple, where we have a set of images with their classes, and we want to learn the function. What are the challenges that we understood more or less until now is that, okay, all those tasks that we see have not a fixed structure. They might have a fixed length on the input, but not necessarily the same complexity. And so these are all the problems that from the technical point of view were already solved in the past. Well, but what means learning, no? This function. So until now we said that, okay, we need to learn this, but what that means in practice? Okay, suppose, now we give a more simple example. We still have some data example. So for example, we have tuple that contains the age of a person in years, and its height in centimeter. And this is the representation, no? Is the representation of the data, no? What means that each one of that, it is one person, conceptually, with their age, for example, 19, and with their specific height, I don't know, 125. Okay, those are the data, no? What we would like to have is something, is a model, no? We said, this is a model that tells us, supposing that I have a new person where I know that its age is 15 years old, what will be its height, no? Conceptually, can be any number, no? Here. But we know that from experience that probably, accordingly to the model that we built, it is exactly the expected height. It is 180. Okay? So what it is the point? The point is that in practice, learning means to find that line. That is not necessarily a line. It depends about which kind of model we would like to use. So the simplest case, no, is the linear model, so just a straight line. A more complex case might be a logistic regression, a logistic fitting. That means that you use a more complex one, no? But if we think, no, what want to do is conceptually, this is what we want to have in practice, no? So we have a set of data points, and we would like to find which is the best model, which is the best line, conceptually, or whatever you choose, that describe as much as best my data, describe in terms of prediction, future prediction. So future prediction means that if I have a new data point, then I can find its 8. Okay? So basically, this is what the current AI system learn behind the hood. So this is what I show you here is a very simple case, is a very simple model, no? So you must imagine, and I will go through that later, that this is actually it is on the extreme. So that means that instead of having just 2 dimensions, we are working with several dimensions. For example, we can work with multidimensional version of that, multidimensional data point, but they are multidimensional from our perspective. If you think in terms of house, no, that is the simplest case, each one of the feature in the input represent 1 dimension of your problem. 1 dimension, 1 mathematical dimension of your problem. And as well, the output. So if you have several classes, that means that you have potentially several added dimensions. No? But just for saying that in the plane, it might be, let's say, simple, not trivial necessarily, but we would like to find among all the possible lines, which one is the best to predict our data. No? But if we think in terms of 3-dimensional space, maybe what we need to find is the plane, no? That exists and that best predict all my data. And this is true not only in 3D, but it is also true in multidimensional, where basically I don't have a fixed number of dimensions. So I have a fixed number of dimensions because I fixed at the beginning. But this doesn't mean that I need to work in 3 dimensions only. I'm working in thousands of dimensions. That's the typical input side that the actual system might face. No? And as humans, we are not able to see how it looks like 1,000 of dimensions. It's not possible to have a graphical representation. So, but the intuition remains the same. So if in the plane we want to find the best line, and in the 3 dimension we want to find the best plane, in the multidimensional space we want to find the best hyperplane, in case the model is linear. Fine. More or less fine, no? Because finding the line, it is typically regulated by some parameters. So, for example, in the generic formula of a line, no, that it is described as follows. No? Have a parameter that regulate the slope of the line, so how much with its orientation, no? And the base that tells you in which position it is. So likewise, the A tells you the orientation, just the orientation, while the B tells you, once you set the orientation, where it is, no? Those are the parameters that regulates. And so once we fix the model, the class of model in our example is the line, we need to find the parameters. And this is what it is in practice means learning. Among all the possible parameters, finding those numbers that best predict our data. This is from the mathematical point of view. And just to also provide you how the things are getting bigger and more complicated, here we might also have, and we're still in the case of supervised learning, we want to have an input image that means that have thousands of dimensions, and we like to predict, for example, the depth of each pixel of the image. No? This is a color map that tells you which is the estimation for each pixel in the input image. It's still conceptually a mapping function between the input and the output, but clearly what it is different from before is that we are working not necessarily with a linear model, like the case of the line, and we are not working with so few dimensions. Here we are working with non-linear and complex model. We can also work with linear model, but the point is that we are not reaching the performance that typically we are seeing today. Okay, so to achieve superhuman or human performance in this complex task, you need to work with high-dimensional space in input, high-dimensional space in output, and a function that it is not the linear one. That's the point, the mathematical problem behind the story. And in that sense, what it is used and what it is in place today is the use of the deep neural network, that it is a very complex formulation that works in stage, the layers of the network, and conceptually what it's so powerful for two reasons. The first one is that, okay, basically what it comes in the beginning, the input, it is somehow processed by the first layer, and then it is the output, it is then processed by the second layer, and so on. So it basically contains this subsequent stage of refinement of the information until it produces the output. Remember that. But from our perspective, this is just a big machinery that contains the mapping function, that learns the mapping function from the input to the output. Okay? The other point is that instead of using a linear model, it uses a non-linear model, in the sense that those neurons here are not invertible because they are going to clipping. For example, in this example, we are using the ReLU and they are clipping the input. They are below a certain value. And this allows you to build a complex function as this one. This one is not necessarily one line, as you saw, for those that notice, but it is just a piecewise aggregation. Concept is like each one of those can come from one neuron. And you can push further to multiple dimensions, you can push further to by enlarging the number of neurons. But the point or the behind story is that, okay, if you think in terms of this complex model, now, basically each one of these line, okay, that you can see here, the connection between the neurons are parameter. So basically are exactly the equivalent of those two. So there are parameters that regulate conceptually the slope, and there are parameters that regulate the interception with the axis. And who they are, technically speaking, exactly the brown one are the bias, the interception, and the gray one are the slope, plus this nonlinear function and plus all these subsequent stages. But from our perspective, okay, it's not so interesting. It's just to understand that the complexity that it is behind is very big, no? And how we are going to use this complexity, we will see. In the first stage, to solve a complex task like this one, but later, and here it comes the second approach of the unsupervised learning. And what is the paradigm shift here, no? The paradigm shift exists where basically what you have is that, okay, do you remember that previously I told you, okay, I have this set of input and output, and I need to learn the function that let me pass from one to another. Now, ideally, the behind story is similar, but the problem is that now I would like to somehow learn this function, but conceptually without having the output, the y. That's why it is unsupervised, no? And so the idea, or if you like, what it happens in practice, is that instead of building directly the mapping function from the input to the output, what I need to do is to learn and characterize how my data looks like, no? And just to provide you an example, no? Suppose you have a set of face. Okay, you have a set of image that contains face, and okay, first of all, how you can, let's say, summarize them, no? As a machine, or if you like, initially as a machine, you cannot do that. In the sense, maybe you can compress the image, but ideally, all those are full image. As humans, how you like to summarize that? If you want to, for example, classify the motion that the person that it is present in the image express, how you can summarize that? Potentially, because you learn that exists some, for example, some muscle that are moving in certain position, no? If you are able to extract that information, okay, so the position, conceptually, the position of the face, no, not the image of the face, but the position of the muscle, no. What you can do, you can conceptually do several things, but one before the other, no. The first thing that you can do is that basically you can describe an image, even if it is not be of the same person, by how those muscles are positioned, okay? And so from the information point of view, this is much more compact than having an image that potentially might be 1,000 or 100 of pixels, no? So But on the opposite, another operation that you can do is that potentially, if you are able to correctly do that, again, no? You are able also to better classify the emotion of the person. So the point is, I don't have the supervision, but what I would like to find in automatic way is, in our example, exactly those muscles and their position, okay? And what it is so-called, this part of the field of study, is that, okay, what I would like to do in practice is to learn representation of the data directly by the data itself. The data itself, in our example, are the image, and the representation of the data from our perspective is the muscle. Now, I have done an example where it is explicitly clear what these, let's say, common and the so-called latent variables are. But technically speaking, and in the real-world application, this is done completely automatically. And that means that you don't necessarily have this exact evidence that those are the muscle of a face. But there are some recurrent, from our perspective, is something that it is recurrently present in our data. But if we are able to learn this representation of the so-called latent variable, we are able, on one side, to be more effective also to solve supervised tasks in the scenario where potentially we have very few amount of data, but then we are also able, and here the story will become interesting, we are also able to generate new samples. Suppose that those are the muscle that we identified in the previous stage, okay, the face, but described in terms of its muscle. Those are our latent variable, no, described here. If we have here, what we can also potentially learn, is that from our perspective, it didn't change so much, because it's still a mapping function from a certain input to a certain output. But the nice part is that if we have a disposition of the muscle encoded in the latent variable, we can have the corresponding image. The corresponding image that it is not necessarily present in the original data. That's the point. Because conceptually, we can also, by hand or randomly, decide which is the position, in our example, of the muscle, and this will automatically be converted into a real image. And this is how it looks and how it works, basically the generative system. Because basically what they learn are those latent variables, and by transforming a normal distribution that basically is just a random sampling on the latent space, the latent variable, we are able to transform this random selection in something that it is real. This is one kind of generative model. And just to show you also some example in that sense, here I have reported some generated image, for example, of cats or of building. Why the system is able to generate from scratch those kind of image? Because it saw many examples of cats. And conceptually, he synthesized behind the scene automatically what are the latent, which are the intrinsic characteristics of a cat, which are the intrinsic characteristics of an image that contains a building, and so on. And so, having synthesized the latent variable, no, they are able then to generate a new one. What's the point? From the usage point of view is very interesting, but from the mathematical perspective is not so, say, not so much different than doing that. So conceptually, what they have done is that those lines conceptually represent, no, the latent variable that you want to learn. But this is done automatically. Fine, but just for saying that it is not so far from what we saw. Is completely different from as approach, but not as a mathematical machine that is behind. Another interesting thing of the latent space, the latent variable, is that conceptually can be mixed. So suppose you have latent variable for the underworld image, and you have latent variable for donuts. Conceptually, those are latent. That means that are not explicitly the image on itself. But that means that if I'm mixing the latent variable, potentially I can produce something that is conceptually in the middle of the two. And depends how much I go in one direction or on the other, I will have something that is more on the side of the donuts or more on the side of the seaworld. And similarly, if I was able to learn, here come the story and the problem, no? If I was able to learn a certain style, as in this case, and also I've learned the latent variable of a certain animal, potentially I will also able to generate something that it is in the middle. So something that potentially it is similar to a certain style and contains a certain image, a certain object or person or animal, and so on. But here comes the part of the story, no? Because when I'm doing representational learning, but also when I'm doing supervised learning, conceptually is likewise, I also not learning just a function, as we saw. No, I'm not just learning this function, but conceptually I also memorize somehow the point in the training set. That's the point, because otherwise I wasn't truly able to determine which are the latent variable for this style, no? That means that learning means, on one side, also memorizing. This is part of the story. Just to conclude this part, I would like to show you the architecture of the LLM. They are the generative models that are behind ChatGPT, Gemini, and so on, that we are using. Here, the learning task is what is called the autoregressive language, that basically what it learns is to predict the next token, starting from a certain sequence of tokens. What are the sequence of tokens? Is the words that were before. So, for example, you have a piece of text that it is start, that it is just a reserved starting point. Then you have the token it and takes, and the output of this is the next token that it is expressed as a probability distribution on top of a fixed vocabulary. It is no more than this. In the middle, there's still the mapping function that we talked until now, The architecture is huge, but it is basically neural networks that I presented before with billions of parameters. Yesterday or the day before, it were released a large language model with trillions of parameters. What that means, when we hear this kind of sizing, no? That basically the number of those are trillions, are billions of parameters. That means that we don't have just two parameters to decide, so just the slope and the intercept, but we have many choices to done. That means that the training will be much heavier from two perspectives, the computational point of view and the data point of view. But again, from our point of view, is nothing conceptually different than finding that. Okay? Keep that in mind. The only thing is that in this case, in the case of the LLM, what we are going to generate, or if you like, what we predict, is the next token in the sequence. And that's why also you saw that the generation process, you have these, let's say, discourses that goes, the generation doesn't come all in one place, but it is first emit the first token, then the second, then the third, then the fourth, and so on. Because anytime it uses what it is generated until that moment as the input to generate the next one. Fine. If we are on the same page until now, we have understood that, okay, learning means also memorizing something, and this will arise a problem from several perspectives. So, and one perspective is for sure the right to be forgotten. So anyone, and this is the case for any kind of AI system that today means any kind of deep learning based system, no, that use user data. You can ask, if you are aware that your data were used for the training, you can ask to be removed from the training data. Because this is conceptually also something related to copyright infringement, because potentially some company have used copyrighted data for their training. And potentially this is also a problem that it is related to the problem of bias, algorithmic bias, because conceptually it's true that, okay, you have some data, but then you see that the model operates in a certain manner, unfair manner, and you would like to correct. Okay, one way to correct that is, okay, I would like to revise the input data, technically speaking, this is the technical part. You would like to revise the input data in a way that the model works in a more fairer way. Nice. All those things are absolutely correct from, as humans, our perspective. But I would skip this slide, but from the point of view of the technical part, okay, they are not very practical. Why? Because what it is let's say, the trivial solution of not using a certain data, okay, is the trivial solution is, okay, I would like to have a model, this is the formulation, that it is obtained from the same training data, but without the data that I've asked to be removed, okay? And that it's That's fine from the user perspective, but it is not always practical from the business point of view. Because training that kind of model, just for an example, the ChatGPT-1 might cost over 4 millions. So over $4 million for training the model once. Okay, this is the kind of size. Note that in these 4 millions there is conceptually everything. There is the power that it is used. There is the salary of the people that are going to maintain the systems up. There are as well the rent of the space or the price of the data center and so on. So everything is in. But for saying that training this kind of system is not easy. It's not easy at all. And that means that you cannot conceptually spend 4 million anytime that someone asks you to remove something, because otherwise basically you kill as well the business on the other side. That's the practical problem. And so if you remember, if a learning was conceptually passed through from the training data, understand which is the best model that we can have. This is the learning. Okay, the machine learning setting. On the opposite, what we would like to do is conceptually, ideally, is to avoid this flow. So suppose that those are the data points that you ask to be removed from the training data. In the classic approach, you need to remove the data, you need to pass through the learning procedure and output the best model. The machine learning what to reach the same result, that potentially it can be resumed by or summarized by this model with these blue lines. Conceptually, likewise, you have changed this part of the prediction model to this part, new part, because conceptually you have removed that data. This is what you asked for, and this is what it happens or must happen in the model. But the point is that, okay, the machine learning problem would like to straightforward pass from the previous model that you have in production to the new one without doing the full retrain from scratch. Because it is, primarily it is too much computationally expensive, and potentially you also don't have all the original training point for maybe some other business scenarios. Just to also understand another perspective, supposing that you have several classes, if you remember the multi-class problem, no? And here we have a representation of the latent space. So a bidimensional representation on how those classes are present in the latent space. What we potentially would like to achieve if we would like to remove an entire class is that, okay, those data points are still present. This is the original model, and this is the retrained one. This data point is conceptually are moving on a side, respect the other classes. Look that now are somehow in the mean of the other, because those are conceptually the unlearned data point. So what you would like to expect from the system is that all the all the automobile are wrongly classified. But this is expected because this is what we want to achieve. Imagine that this, instead of vehicle, are, for example, religion. No, maybe you wouldn't like to have this part of the system that somehow classify a person according to its religion. No, and so this is the problem. I will not go in the technical detail, but this is ideally what we would like to have, what we would like to achieve. We would like to have the new model without retraining from scratch. And which are the dimensions, no? Which are the kind of unlearning and the kind of approach that we would like to keep attention of, no? So the first one is the granularity, no? The granularity tells us conceptually which kind of what we want to unlearn, no? And until now, we conceptually think in terms of data points, so a single point. So, for example, my specific image, one of my specific image, or my house, no, in our example. But this is just a point level, because it's just one single instance that I would like to remove from the training set. Another possibility is the identity level. Identity level means not only one specific example of my person, but everything that it can be linked to my person. So not only the image, but also, I don't know, my medical records, everything. Another thing is talking about concept level unlearning. In this stage, for example, I don't want to unlearn a specific person or a specific data point, but conceptually I would like to unlearn all those persons that have a mustache, because maybe this produces a certain bias in the system, and so I would like to conceptually remove the concept of mustache from my model. Another possibility is class level, as we saw in the example of the latent space. For example, I would like to remove all the airplane of the automotive. This is more or less a simple case. More different one is the feature level, and this is the case, for example, of the religious or of the gender. So conceptually, I would like to have a prediction function that it is likewise, I don't have a certain input feature in my training data. So in that sense, it's like I'm ignoring the religion or the gender from the technical point of view. And lastly, the temporal level. So I would like to forget conceptually all the data that belongs to a specific time frame. Which are the unlearning approach? We are talking about exact unlearning. Exact unlearning means that I would like to achieve exactly the same model that I'm obtaining if I'm retraining from scratch. Retraining from scratch means I'm removing the data that I would like to remove from the training set, and I will retrain from scratch. And the other one is the approximate unlearning. The approximate unlearning is basically exactly what I show you here. This is the case of the inexact unlearning. So I would like to achieve the same result, but without performing the full retrain. Okay, what I need to care about? There are three aspects that I need to evaluate when I'm working with this kind of problem. One is the efficacy. So after the training process or the unlearning process, I was really able to forget what I need to remove, yes or no. This is one point and one point of the evaluation that I need to care about, because potentially I can do whatever I want, but then there are still conceptually traces of the data that are supposed to be removed. The other point of view is the utility. So if a certain model performs in a certain good way in terms of prediction, so it were a good model because it was able to produce some images or was able to predict correctly the price of the house, we are still able to predict correctly the price of the house, because from the other perspective is, so potentially I have removed the data, fine, so the efficacy is good, but my model were completely destroyed by this process. That means that is still is not usable for the business task that I have, or whatever task I had. The last point is the efficiency, because as I told you, retraining from scratch is the time and energy and money consuming. And that means that in terms of power, money, and time, I would like to obtain the new model in an efficient way. In other words, it must be much better in terms of computational complexity than retraining from scratch, because otherwise it is preferable to retraining from scratch directly. So in other words, if passing from here to here it is efficient, it is okay. If I'm passing from here to here, it's more time consuming than doing full retrain, is not convenient. But this is one of the dimensions that it must be taken in consideration, because sometimes maybe, okay, I have achieved a wonderful result, but okay, at the end I took more time than redoing the things from scratch. This is not acceptable from our perspective. And I have done in the sense that I hope I try to convey what it is learning and what it is unlearning, what are the difficulties. I didn't go in the current state of the art, even though I'm currently working. I have also several publications from the technical standpoint, but I guess probably this is more, even though I guess I was too technical, but I hope it was nice for the audience. So I don't know if there are questions or...
Thank you, Professor. I don't know if there are some questions for Professor Stilo. No, there are not. So thank you once again for your rich presentation. It was very, very insightful.
Thank you very much.
Okay, so we can start the second part of our morning and presentations. And now I have the pleasure to introduce you our next speaker, Professor Anna Tozzi, who is quite an institutional figure for our university. Professor Tozzi is a geometry professor, and she has also worked as Vice Rector for International Affairs from 2004 until 2019. And after this, she has been appointed as the Rector's Counselor for Internationalization Policies. Today, Professor Tozzi will deliver us her presentation titled Artificial Intelligence Ethics and Ethical Moral Relativism, and she will focus on several ethical aspects around AI, which is a hot topic in the contemporary global debate. So now I leave the floor to you, Professor. Thank you.
Good morning, welcome to all of you. It is a pleasure to be here. And I'm a mathematician. So I'm not a philosopher, I'm not a sociologist, I'm not a technologist, I'm only studied the foundation of mathematics, that in my opinion are the foundation of humanity, of the humanity growth. I will present some objective opinion, ideas, and then some of my own ideas, my own perception of what is ethics and moral for artificial intelligence. I sit down. Okay. Can you hear me? Yes, I think so. Okay. Ethics of artificial intelligence are, as defined from previous speakers, as a set, or should be, a set of guiding principles that stakeholders, and who are the stakeholders, use to ensure artificial intelligence technology is developed and used responsibly. So each word here has different meaning according to the feeling each one of us is reading the same words. This means, or at least the aim, is to taking a safe, secure, humane, and environmentally friendly approach to artificial intelligence. In this week, we, in the sense this group of people analyzed some aspects of this complex and fast-evolving field of study and concern artificial intelligence threats and how to mitigate them. And this is a huge problem because the technology is going very fast and the remedial measures are trying to follow this fast pace of development. Artificial intelligence the right to be forgotten. Just now, the previous talk was about, machine learning sometimes learn wrong things, and we should teach them to unlearn what they learned. But this is another problem, because you do not delete everything. You cannot delete everything. So these wrong models become a part of the data where new technology, new programs will grasp information. So this is an important, very important issue. Are privacy and intimacy still guaranteed in the era of artificial intelligence? Then yesterday you had artificial intelligence, after my talk, and the protection of fundamental rights. This is a very important issue. Newspaper, literature is full of breaching of these fundamental rights, even not intended consequences, but the program produced unintended, dangerous, bad consequences. So there are many issues, privacy violation, intellectual property issues. We should ensure that artificial intelligence is human-centric, transparent, and accountable, applying the human rights principle throughout its development and deployment life cycle. Artificial intelligence preventing discrimination. You know, the big, Professor Stilo was mentioning the bias from Amazon. They wanted to have a system to recruit people, to analyze the curricula of people, giving marks to this curricula. Since the representation of women was scarce, the system decided that women were not important. So deleted each file that contained the word woman. So Amazon discovered that the system was hating women, and it was a big scandal. They had to apologize, they had to correct. So this was not, certainly they didn't want this result, but the system did. Okay. Ethics in action. Donatella was speaking about this, and she was looking at the ethics of artificial intelligence, but the meaning of ethics in several fields, philosophy, religion, jurisdictional, etc. And linguistic competencies yesterday. So students use ChatGPT to do homework. It is not correct. It is academic dishonesty that must be punished. But artificial intelligence can be a useful tool for teaching and for learning. But we need specific rules that students, teachers must follow to guarantee the honesty. Then, these are different perspectives, different point of views from technological, legislative, philosophical, and regulatory fields where the word ethics is intended in a specific and limited to the field of interest, meaning. Thus, we should ask, what is ethics? What do we mean with ethics? The word comes from ancient Greek word ethikos. That means that it derives from ethos, meaning character, personal disposition. So ethics is something connected with the behavior, the character of a person, of a group of persons, and refers more than the character to the analysis and evaluation of the correct conduct and the good character within the society. But analysis and evaluation by whom? And against what criteria? How to decide if something is ethic or not? So, what I would like to speak with you and giving my suggestion or ideas is what is ethics for a normal person? A normal person like me, not a technologist, not a philosopher, not a sociologist, not anthropologist, not a psychologist, not a jurist, not a politician, not, in the daily life. Ethics is a system of principles that includes ideas of right and wrong, bad and good, and how people should or should not behave in general in specific situations. But ethical, the word, is often used instead of or together with moral. But are we sure that ethics and morality are the same things? I'll try to explain my point of view. Where if we often say, oh, this conduct, this situation is not moral, is not just, is not ethical. And so we refer to three different levels, to different sets of principles. And what is moral or no moral is something that is in our own principles. Is not external, is internal. Okay. The individuals develop their own concept of wrong, right, but good on the basis of their family teachings, personal experiences, social group to which they belong, to which they interact. Thus, which is the difference between the two words, two concepts, morals and ethics? Morals are individual principles of right or wrong. Ethics are external principles, rules, code that comes and are right, have the right to exist because they define the boundaries within which an action is admissible, but is not the real moral judgment. Morality is internal and personal, shaped by our beliefs, values, and experiences, whereas ethics are external rules. And external rules that say what is correct within a specific context. And to be correct doesn't mean always that is moral. It's the easy consequences and the easy field of application is the professional deontology. There you have external rules. For instance, the doctors, the lawyers, all the professionals have a deontological code with precise rules. So, although generally an individual was taught by their parents' definition of right or wrong as a child, morality can sometimes become confusing. Complex moral and ethical issues have been at the heart of politics, philosophy, and religion since the dawn of civilization. But in our life, working or personal life, we had experience. We have faced the situation when we had to do moral decision, to make moral specification of what was right or wrong. And in these cases, in cases of dilemmas and doubts, only our personal values are followed. And it's important to have moral values. So, moral values and moral code needs to be framed in the specific context when the problem arises, as exactly as the legal system and the articles of laws must be interpreted and adapted to the situation. When I was a child, I was thinking, but why lawyers exist? There is the code, there are the laws. If someone infringes a law, is guilty. If not, is not guilty. But this is, we know every day that laws must be interpreted. Also moral laws must be interpreted. So this means that for ethical decision making, it can be essential to learn how to differentiate between moral and ethics. Explore the nature of making sound ethical decisions and know how to make choices that align with our moral compass. While both concepts of moral ethics involve differentiating between right and wrong, they describe two different approaches to the decision-making process, or better, two different levels of the process. Morals refer to personal values, so we value according to our belief. Ethics, we compare the action to the general code, the general ethical code. Certainly, an ethical code, what artificial intelligence ethicists are trying to do, and as Donatella was explained very well, it is almost impossible to grasp all the stuff. But an ethical code must have rooted in philosophical ideas, but trying to find principles that are valid worldwide, especially with the artificial intelligence that is not closed in the boundary of a nation with specific laws, specific ethics, but artificial intelligence is spread. So we need to find general, universal principles. Of course, the two levels, moral and ethics, produce dilemmas. An action can be ethical, that means respectful of the ethic code, but not moral according to our belief. And it can be even just according to the law, but we consider this not moral, not morally accepted. Many times when we read about the sentence in the court from some crime, we do not agree with the solution, even though it is right. It is specifically well explained by the code, the national codes. At the end, for the moral decision, we are the sole arbiters in the decision. So, now why we are speaking on this? Because the AI technologies are becoming self-learning, human-like, semi-autonomous, and they are used to, or considered as an alter ego, as a human that can do decision, and sometimes we consider better than humans can do. And this is the big mistake. AI is becoming integrated in various aspects of contemporary society and business, transforming how we generate knowledge, make decisions, and carry out tasks and action. And this produces new responsibility gaps, and ethical tensions can emerge. Emerge. These arise from the blurred interdependencies between data, artificial intelligence, and the diverse role of humans play. Developers have the task to make the product useful and producing wellness, richness for the company. Users, normal users cannot do much. They use what they find. Managers have a different task, different aims. Regulators, they try to make regulation to manage the situation at the best. And this different human player must be all the result found in their accountability for unintended consequences. So we have the first question that we have to ask to ethicists, artificial intelligence, are you sure that what you programmed is not hurting people, and to which extent is harmful? In this big mess, government, intergovernmental organization, as United Nations, UNESCO, World Bank, are trying to fix boundaries to this matter, to fix rules. So there is the Declaration for Responsible Development, the European Artificial Intelligence Act with the Fundamental Rights Impact Assessment, all in evolution. And also institutions are producing regulations, trying to, as Institute for Ethics in Artificial Intelligence, Data Science Center, I don't read, European AI Alliance. Every day new bodies try to make order in this big problem. But in any case, we are not really aware that we are allowing algorithms, because we speak of artificial intelligence, but artificial intelligence is not an entity, it's a tool that is doing things according to the programmer. The programmer, that means the algorithm that the programmer produced. So we are allowing these algorithms to decide what we buy, what we read, what we should or better we must like, not to mention imperative medical and judicial recommendation. If you open Google, Every day you have advices of, you have a problem, your knees, but this is a remedial, wonderful remedial. More and more, artificial intelligence is used, programmed, to make decisions with ethical relevance, consequences, social, economical, personal consequences. This means that each algorithm chooses and uses an ethical moral framework, explicit or implicit, that shapes those decisions. Thus, the first question is, how and to which extent does artificial intelligence take ethical decisions? To answer this question, it is useful to analyze the process that we, the human, follow to make an ethical decision, especially when conflicting beliefs, interest, and information complicate the decision-making process, or when moral and ethical issues cause individual frictions and questions to their belief. So the first thing that we do, if we are responsible persons, is to identify the problem. Identify the problem means to decide the method to identify the causes, the variables behind the problem. For instance, one, but there are many, the 5 whys method. So the first choice we do is the method. Second, we gather information. So we identify the problem, identify the variables, identify which are the bodies involved in this responsibility, and we ask information. We ask for relevance, we ask for evidence of these causes. And then, after this consultation, we start to make possible decision. And we weight one against the other, the possible decision we can take. And we look and use different ethical principles, consider all possible outcomes, anticipate potential harm. Then, okay, we select one decision. And before to take the final decision, we analyze again this decision, the consequences, which are the people in danger, which is each decision in life has negative consequence to someone. Is something that is not avoidable, because each decision decides what is good, what is not good, what is right or not, what is feasible, not feasible. And we human, we try to minimize these consequences. We try to help people that are in danger from this decision. Okay, and we look, we identify, we try to have a landscape of short-term, long-term consequences. And then we finalize the decision and identify the people that are in danger, can be hit by the decision. We try to solve the problem for these people. I'm speaking of a human being with the capital H in front of human. All the above imply understanding our personal moral philosophy and improving our decision making. Then we translate this process to algorithms. The programmer, the developer, chooses the method to identify the problem, collects a huge amount of information from the data. The data that artificial intelligence can analyze, collect is unimaginable for a human being. So, in this sense, they have a lot of data. But first question, who is guaranteeing the suitability, reliability of data? Remember the case of Amazon. The system decided that women were not important because women are not represented in computer science. So collect information, applies the code of ethics, What means to apply the code of ethics? The programmer, developer, decide which principle are important, and which are not or less important. In case of a moral disagreement, adopts the solution that she consider the best. So, when we say artificial intelligence decide this, it's not true. It is the programmer, the developer, that decided. So the second question is, what are the risks of using artificial intelligence in ethical decision making? The main risks include over-reliance on artificial intelligence. To make artificial intelligence, that as I was saying before, which is not an entity, is a tool. It is like to say that a car is guilty because it was investing in killing people. It's not the car. The car is a tool. It's the driver who was making wrong use of the car. So the over-reliance on artificial intelligence, loss of human agency, potential artificial intelligence bias, lack of transparency in decision-making process. So this developer, how reached the result? These risks can lead to ethical dilemmas or unintended consequences if not carefully managed, or at least understood. So the question is strictly connected with the technical ones. Can artificial intelligence systems understand what they learn? So again, it is a linguistic but deeply fundamental meaning of the difference between learning and understanding. Learning is the process of acquiring new knowledge, new data, and artificial intelligence can eat a lot of information. While understanding is the ability to grasp the meaning of what knowledge and apply it in different contexts, in new contexts. Learning involves memorization and recall, whereas understanding requires making connections, seeing patterns, and being able to explain the why behind the what. Artificial intelligence can memorize a huge amount of knowledge, certainly unimaginable for a human being, but it lacks of intrinsic understanding, as it identifies patterns, but does not comprehend context or reason beyond the association. The system does not know why it's connecting those data. Thus, is it correct to say and think, as often we read in the newspaper, that artificial intelligence is more intelligent than humans? Again, what is intelligence? What do we mean with intelligence? Intelligence is the complex ability to reason, understand, learn from experience, adapt to new situations, to solve problems, and make informed decisions. It encompasses a range of mental processes like abstract thinking, memory, logic, creativity. This opens another question again, concerning words. What means intelligence? The word intelligence comes from Latin intelligentsia, which comes from intelligere, to understand, to comprehend, and the word is the composition of the preposition intus, inside, while the verb leggere is grasp, collect, read. So the word intelligence means the ability to read within, to grasp deeply what is not visible in surface. There is a second interpretation of the word, changing the preposition intus with inter, between. So intelligence in this case is the ability to read between the lines. That is to grasp relationships and the interconnection between different aspects of the reality. In my opinion, intelligence is both, can be interpreted as both. bot interpretation. Consequently, while AI systems can outperform humans in specific tasks, so in eating a lot of data, a lot of information, so predicting market trends, detecting fraud, analyzing complex data set, they lack true general intelligence. The power of artificial intelligence doesn't come from innate reasoning, cannot make reasonment. Thus, we should take this in mind and be aware about what artificial intelligence can, that means knows how to do, and what cannot. Artificial intelligence is not a new god that will dictate new tables. Artificial intelligence is a useful, very useful tool, but we must use it in a proper way. So the other question, what are the risks? I already said the over-reliance on artificial intelligence will make the risk to lose the human agency, create new bias, to have no transparency in decision-making, and create new dilemmas. But how does artificial intelligence influence moral decision? Moral are not ethical, are not the same, they are different level. We must ask ourselves an imperative question: whose morality is being programmed into this machine? AI systems are not moral or ethical. They are tools. But inevitably, the underneath algorithms are not neutral. They reflect the data, the way the data are selected, the way the programmer is making them work. So this is important now that we are giving to artificial intelligence a very strong importance. And we ask, can or should AI agent exhibit moral behavior comparable to human? This question is connected with something that comes from antiquity, from 6th century before Christ, which is the moral relativism, which is a good thing. Moral relativism means that there is not a general truth or general good. It depends on the situation. It depends on the group of people. But I don't want to take more time for you. This from Protagoras. I want just to underline what Hume said. Hume distinguished between matter of fact, which is ethics, from a matter of value. A matter of value is the personal idea of what is good, not what is considered good. But at the same time, Hume was underlying that some sentiments are universal. This debate has shaped the history of humanity in 3,000 years. And still discussion is good, the discussion is going ahead. But now artificial intelligence, what should learn from this? I go fast. My own view. I think that there are universal human rights that cannot be touched. They must be granted. But each situation, each judgment, each decision must go through a cultural dialogue and adaptation. This is very difficult now. In this society where moral relativism became utilitarianism, very selfish, very strong utilitarianism. So the developer, the society, look at the money, not the moral. So this is the real danger. In this society, we must make the right place the culture. Culture of developer and integrity are fundamental. But the technologists now are have rejected the objective truth. They are building a new world. And this was creating a fear, sense of impotence, and also movies, television with the disastrous, very... So I don't think that artificial intelligence will be like in the films, but certainly this time of uncertainty outlined the need for a thoughtfulness around this developing system. This is the last slide, promise. Artificial intelligence does not create ethics. We, the humans, do, always. The moral compass of technology will always point where humanity set it, but humanity must be humanity. In tackling a problem and responsibility, the enemy number one for me is ignorance. Exactly as at the time of Socrates, Plato, Aristotle, and now, if we look at the recent literature, because the literature about the ethics of artificial intelligence is very recent, they are reproducing the steps of civilization, starting to think what is good, what is not good, what is human. So now knowing the past processes is fundamental. Technology without culture is poor and arid, even when it solves problems. Solving problems without culture can only create new problems. And we are now exactly in this situation. These are the challenges for the future that we all must face with awareness of our limits, respect of fundamental rights, and attention to human values. This is my opinion, and this is, I hope that things are going this way, and we, academic community, which is our duty, we do not dictate the truth. We must teach the students to use their brain, not to delegate the decision to technology. They must manage technology, they must possess technology, but to use them according to their personal values. That's all, sorry. Thank you.
Thank you, Professor. We have some space for Q&A if there are questions for Professor Tozzi. One question for Professor Tozzi.
Thank you so much. I wanted to ask you about your perspective about bias.
About
bias. One answer that we hear whenever these scandals happen is, yeah, but the computer did, and rightly you focused on the attention on the programmer. And very often, when they ask the programmer, the answer is, oh, I didn't think of that.
Yes, this is the problem.
And maybe instead of trying to build a tool that is devoid of bias, we should actually try to reflect on the bias that we all have.
I think that it's impossible to avoid the bias, because when the amount of data is so huge, you cannot control them. And if you control, you are limiting the result. So in my opinion, it's not possible to control. What we have to do is to warn about the possible bias, that what is coming out from the computer is not the Bible, is not the truth, is useful and must be studied according to what you want to realize. This is my opinion, but I think the only thing that can be done, because the technology is going too fast to prepare remedial measures on time. We are always late.
Another question, Professor?
Thank you for your excellent presentation. I want to ask you, despite the culture and the context and each country policies, we have a society where the capitalism system dictate so many rules. So how can we regulate under these market rules, especially the company's interests?
This is the value, the human values, which are different from ethics, because ethics, the code exists. They decided the principles 4, 5, 11, 12, but then who is controlling that these principles are followed? Since the procedure under the programs are so intricate, you cannot control this. So, for this reason, I was just finishing that culture and humanity is the only saving situation. But we cannot ask a capitalist to give up. We have to go in a parallel way. And be alert. Be alert. This is what we must teach our students.
Thank you, Professor.
Okay, we're now moving towards the end of today's session with our last speaker, and I'm very glad to introduce you Dr. Alessia Fonzi, who will deliver a speech on artificial intelligence for preventing discrimination. Dr. Fonzi is a researcher at the University of L'Aquila, DE department, and she works in the area of public and constitutional law. So she teaches and researches in these areas. She teaches also protection of fundamental rights, which is a relevant topic, and she also published around this topic applied to health and education and so on. So, Dr. Fonzi, the floor is yours.
Thank you. Thank you to the organization of this conference, very interesting conference, and welcome everyone to the University of L'Aquila. My presentation is about artificial intelligence for preventing discrimination. I am a jurist, a lawyer, so my approach is a legal approach to the theme. It is commonly held that robots are created with the purpose of assisting and protecting human beings, as well as of making decisions that are fair and more equitable than those made by humans. The so-called 3 laws of robotics, formulated by Isaac Asimov in 1942, constitute an early attempt to outline ethical and normal principles governing artificial agents. They set out 3 principles governing the relationship between human beings and robots. The first established that a robot may not harm a human being, nor, through inaction, allow a human being to come to harm. The second law states the principle that a robot must obey the order given by human beings, except where such orders would conflict with the first law. Finally, a robot must protect its own existence, provided that such self-preservation does not conflict with the preceding principles. There is a fourth law that is subsequently introduced in a book, I, Robot, which states that a robot may not harm humanity, nor, through inaction, allow humanity to come to harm. Unfortunately, it is a very current law, but not applied. So, the underlying framework does appear to be oriented towards a principle of human protection, promoting the use of artificial intelligence as an aid to human reasoning. Robots are devoid of emotions and feelings that may deprive human beings of the necessary clarity of mind required to make fair or equidistant decisions with respect to all the factors capable of influencing the decision-making process. But the use of artificial intelligence systems may affect fundamental rights: privacy, data protection, non-discrimination, and human dignity. In relation to the protection of fundamental rights, the issue of fairness in decision-making becomes a particularly pressing concern. And as a result, a considerable degree of trust is placed in the instruments of artificial intelligence. The perspective to examine the relationship between artificial intelligence and fundamental rights, particularly with reference to the principle of non-discrimination, can be twofold. On the one hand, AI emerges as a phenomenon capable of generating discrimination, so-called algorithmic discrimination. On the other hand, AI may also be understood as a tool capable of preventing discrimination or remedying existing discriminatory practice. The minimization of the risk of discrimination relies on the application of the precautionary principle. As early in 2018, in the ethic guidelines for trustworthy AI, the Commission frequently referred to the precautionary principle. According to this principle, AI systems must neither cause nor exacerbate harm, nor negatively affect human beings. This highlights the necessity of safeguarding human dignity, as well as the physical and mental integrity of the individual. What's the precautionary principle? The precautionary principle can be applied particularly and above all during the algorithm development phase, which must be designed to prevent the generation of both direct and indirect discriminatory effects. The obligation to respect the principle of non-discrimination is enshrined in the Article 2 of Treaty on European Union, which provides that the Union is founded on the values of respect for human dignity, freedom, democracy, equality, the rule of law, the respect of human rights, including the rights of persons belonging to minorities. These values are common to the member states in a society characterized by pluralism, non-discrimination, tolerance, justice, solidarity, and equality between women and men. As emphasized in the summary by the European Union Agency for Fundamental Rights, automation and the use of AI can significantly enhance the efficiency of services and extend to tasks that human beings would not be able to perform. However, it is essential to ensure that AI-based services and decisions are not discriminatory. Discrimination. What's discrimination? Discrimination often arises from the mistaken belief that omitting information on the protected attributes such as gender, age, or ethnic origin can ensure the strict application of the principle of equality by an AI system. But this assumption is not necessarily correct, as the completeness of the data input into the system can provide a comprehensive perspective and, consequently, allow for the assessment of all relevant factors, thereby enabling a decision that is equidistant from all interests. The prevention of discriminatory behavior, therefore, also relies on the ability of AI to test for and detect discriminatory patterns that may be encoded in data sets. So the perspective from which artificial intelligence is to be examined is therefore that of the potential positive effect of using algorithms to render decisions more equitable. In other words, the use of AI can be aimed to detecting possible discrimination as a positive outcome in the sense that discrimination can be identified more effectively even when data are analyzed for potential biases. The identification of potential discrimination through the use of AI and algorithms remains a challenge requiring a dual reflection. The first, concerning the discriminatory potential of the algorithms. The second, regarding its capacity to prevent discriminatory situation. In this way, the implementation of the principle of equality can also be ensured by artificial intelligence. The discriminatory potential of algorithms has been observed in 3 areas relevant to the protection of fundamental rights: employment, justice, and health. With regard to employment, well-known multinational corporations like Amazon have adopted artificial intelligence systems in their recruitment process, based on the algorithms capable, in theory, through data analysis and statistical modeling, of identifying the most high-performing candidates. However, the approach taken in programming these algorithms was not aimed at correcting existing real-world inequalities, but rather at replicating, even within the context of employee selection, the same mechanism of human choice that tend to reinforce the structural advantages of certain groups within their respective sectors. In the specific cases of Amazon, Uber, LinkedIn, the recruitment process was found to favor men over women. It is a gender discrimination. Injustice, facial recognition technology may produce distorted outcomes when the data used for training present critical shortcomings in relation to individuals with non-majority characteristics. Indeed, if the algorithm is built on common data sets that fail to account for specific somatic features, the use of technology may reinforce racial discrimination, whereas it should, on the contrary, to be capable of preventing it. And in health, the right to health, both individual and collective, may be adversely affected by algorithmic discrimination. It has been observed that the analysis of one of the most widely used algorithms adopted by a private insurance company in the United States to design healthcare policies revealed that the medical expenses of Black patients were systematically underestimated by the software, despite identical actual health conditions compared with other patients. The erroneous inference by the algorithm led to the outcome that fewer financial resources were allocated to Black patients, deemed to be in better health, thereby resulting in a clear instance of racial discrimination. So, a distorted use of technology neither prevents nor eliminates the form of discrimination inherent in human reasoning. Rather, it generates them itself as the result of a human intervention in programming machines with the biases that characterized these creators. The central role that artificial intelligence has assumed in every aspect of daily life is an expression of a technological progress that cannot be renounced. However, the essential condition for the use of such tools is their compatibility with the protection of fundamental rights. Otherwise, humanity will have taken a step backward. So, AI for prevention discrimination. Reflection on the discriminatory use of artificial intelligence leads toward a constructive approach aimed at restoring the meaning of technology as a tool capable of supporting human reasoning, in the sense of ensuring an additional layer of protection of fundamental rights, and of replacing it where it is potentially capable of producing discriminatory behavior. The European Union Agency for Fundamental Rights is actually engaged in combating algorithm discrimination through the identification of effective policies capable of contributing to the reduction of bias and stereotypes. Algorithmic data analysis has the potential to produce non-discriminatory results. However, this remains a challenge in which human intervention appears to be indispensable. So, what is the challenges that new technologies pose to the protection of fundamental rights? Algorithmic discrimination constitutes a significant demonstration of the challenges that new technologies pose to the protection of fundamental rights, necessitating a renewed interpretation of the principle of equality. But if equality requires fair competition, in the digital context, this also entails fair competition among the data that the system must process, since a partial view of reality produces errors in judgment, both by humans and by machines they have programmed. Attention! If the initial conditions are inequitable, one cannot entrust the machine with the onerous task of making fair decisions, as it can only process the partial data provided by humans, serving as a mirror of the reality it observes. An example of discrimination in the right of health. Focusing on the issue of health on a global scale, it is immediately apparent that access to even minimal health conditions is still denied to a big portion of humanity. And this inequality will be further exacerbated if only some individuals are able to choose not only to receive medical care, but also to enhance their health, for example, by choosing to live longer or to achieve greater happiness. One might attempt to distinguish between therapeutic enhancement of health and the more aspirational forms. However, in light of international sources, which define health as a state of complete physical, mental, and social well-being, it appears difficult to separate the two concepts. Consequently, while some are permitted to achieve the desired level of well-being, others are denied access even to the minimal content of the right of health. The question we must therefore ask is whether AI is capable of preventing discrimination or of remedying existing discriminatory practice, particularly about protection of fundamental rights and when the initial conditions are not equal for all. This is the real challenge. In the right of health, I think about telemedicine and other tools that can guarantee the right of health, but we are far from the goal. A consideration: if the machine learns to reason exactly like humans, adopting the same stereotypes and biases, the problem will not be resolved. On the contrary, it will be exacerbated. A further aspect closely related to the previous one concerns the protection of the rights of future generations and the associated issue of intergenerational responsibility, particularly with regard to the development of genomic surgery and the attention to emerging genetic technologies by the Bioethics Committee of the Council of Europe. A conclusion: in the input phase. The issue is extensive and requires careful oversight in the use of artificial intelligence, when potential distortion in the protection of fundamental rights arise. The principle of data and information completeness during the input phase could help to prevent the emergence of algorithmic discrimination, as could an appropriate consideration of the precautionary principle. In the execution or output phase, even at the execution or output phase, distorted or inaccurate results cannot be ruled out. Indeed, it appears that the machine or robot is not infallible, and this consideration calls for a revaluation of the principle of no exclusivity, of the role of a human being. A new perspective. Perhaps the perspective to approach artificial intelligence needs to be inverted. AI can function effectively only if humans sustain it in accordance with fundamental principles that must also apply to machine learning systems. The infallibility of the machine seems at present to be a myth dispelled. Thank you for your attention in the hour to go to lunch. Thank you.
Okay, thank you very much, Dr. Fonzi. We can now open the floor for questions from the audience. So just raise your hand if you want to ask anything.
It's time to lunch.
Maybe lunch is, yes, playing a role in this, but the conversation may also continue downstairs. I guess you are joining lunch, so maybe we have some communication before lunch, though.
Thank you.
Thank you very much. Excuse me, just a communication for the location of the meeting for tomorrow, which is in Palazzo Camponeschi, our main meeting. Okay? Please take a note. See you at 8:30 in order to complete the registration. We will meet Professor Rubino, our Vice Rector for International Affairs, and then we will organize the visit to the museum and to the city tour.